Good morning, everyone. Welcome and thank you for joining us for this morning's webinar focusing on our introduction of the LaserFlow EX. This webinar is being led by Rick Dye and Daryl Kuda, Teledyne ISCO's Business Development Managers. This webinar is being recorded. If you have any questions or comments during the webinar, they will be answered at the end. And the recording will be shared with all registrants and attendees later on this week. At this time, I will turn it over to Rick and Daryl.
Well, thanks, Tori, and thank you all for attending today, taking time out of your busy schedule. We're very excited today to be introducing a new product, which is the LaserFlow EX, joined by Daryl Kuda, who has recently been added to the team to help sell and work with you on laser flows, as well as LaserFlow EX. So we're going to go ahead and do a little bit different this time. We're going to kind of do a little tag team. I'm going to start it off and I'll turn it over to Daryl. To get started, what I'd like to do is go ahead and just kind of introduce some of the basics about what is the difference about the LaserFlow EX sensor. We're going to talk about the NFPA standard, which is 820. We're going to talk about some application for Class 1 Division 1, which is what the product was developed for. We're going to talk about some of the beta sites and some of the teams that we work with out there, and we appreciate those customers if you're attending today. Phoenix, Tucson, Victoria, BC, we've had New Jersey, City of Omaha, et cetera, et cetera. So we've done a lot with these teams out there, and we certainly appreciate all their help. Before we get into the LaserFlow EX, I wanted to go ahead and review what we do with the LaserFlow. And this was developed with our flow lab. This is the ISCO flow lab. One of the areas I think we have a big advantage is that we have this facility. This really helps us develop and design product. It does tell us how accurate it is, but it's more for development. We're one of the few companies that have such a facility of this size, so it's been a very, very big help. Let's go into some of the basics of area velocity flow measurement. Q is going to be your flow is equal to the area. The area of flow is done by a level measurement. Level measurement is typically used some sort of a pressure transducer, pressure sensor, or an ultrasonic sensor. The V component is the velocity. Velocity is typically, in our case, what we're doing today is going to be a Doppler velocity measurement. There are a couple different ways of doing that. One would be a contact velocity, which is a sensor on a ring in a pipe, which is what a lot of people are very familiar with. Today, though, what we're going to be talking about will be non-contact, and that's what we're talking about laser, which is not in the flow. So let's go into this a little bit more. So a standard area velocity, you have a sensor on the bottom, typically on some sort of a stainless steel mounting ring. And what this thing does, it goes ahead and it reads a level using a pressure sensor. We transmit a frequency out the nose of that sensor, and we calculate the Doppler shift, or we can read the frequency return to calculate the Doppler shift, which is giving us our velocity component. These are very, very popular, typically in like I&I studies and things like that, where they want to move these around, get a good idea of what's going on in their collection system. But they do have some limitations, so that's where the laser will really help out. One thing we do pride ourselves in at Teledyne is providing the right product for the application. So we have a number of different technologies that we offer. Today, though, we're going to be talking about the LaserFlow. For those of you that have existing LaserFlows, you're going to see there's a little color change with the new design. The new design will be blue, and Daryl's going to talk about that in a little bit. But how do we measure with the laser? And this is a kind of a unique way of doing things, but what we do is we have a ultrasonic sensor in the back of the laser, transmits off the housing that's at a precise angle. We know exactly where the water is. Once we know where that is, what we do is we focus the laser below the surface of the water. So this is really the patent and the uniqueness behind the laser is we're the only ones that go below the surface when we take a velocity reading. There are other meters out there that can do surface readings, but we are truly the only ones that go below the surface. Before we get into the laser, we're going to talk about the operation of the ultrasonic sensor. So one thing we looked at on other designs out there was where the placement of the ultrasonic was, some of the pluses and minuses of existing designs. And one thing we looked at was when they're mounted up and down, they will have a tendency to have moisture that could accumulate on that sensor. So what we did is we mounted our ultrasonic in the back of the laser housing. And what that does, mounted in at that angle, is any moisture that accumulates on the sensor due to a obviously humid environment will just drip right off the face of that ultrasonic. So you don't have to wipe that thing off as well as even if it goes underwater. So we have a deflector plate, and the reason we put the ultrasonic back there is because every ultrasonic sensor typically has some sort of deadband, and this one does as well. The deadband is normally about a 12-inch deadband, and so what we've done is we've taken that into account in the design. So we transmit off the deflector, we hit the water surface, but where that placement is, now we have virtually a zero deadband system. The water can go all the way up, including submerging the laser before it will not read the level. We have a range of 0 to 10 feet, so it can be 10 feet above the minimum water depth. So it has a very, very good range. We can read down very, very low levels as well. So let's talk about the laser operation and how we do what we do with the focus. So the magic behind the laser, a typical laser pointer has a fixed focal point. So that's why you can see a laser for quite a distance. What we do with the laser in our case, though, is we change that focus point so that we know exactly where we want to get our information reflected back from. In this case, we know where the water is based on our distance to the water on the ultrasonic level sensor. Once we know where that is, we focus the laser in a very, very precise point. In that area, what we'll do is transmit, again, a known frequency, like any Doppler system. We measure the frequency return, and we can calculate the Doppler shift or the velocity of that water. So give you a better idea, kind of a front side view of what we do with the laser is we, again, do a level measurement. We know where the water is. Once we know where it is, we focus that laser. Where we focus at is known as a converging section or point of convergence. That's where we want to get our information from. So we're taking kind of a little bit of a slipstream of what's coming back from that laser. We're getting reflections off the entire laser beam, but most of it's very weak. What we want is the strongest signal, which is coming from that point of convergence. When we take a reading, we're taking 5,000 spectral velocity readings, and we do that in roughly 2 seconds, which is pretty amazing what it's able to process in that short amount of time. By comparison, if you look at a standard area velocity sensor, they take roughly 500 readings. So the laser's doing 5,000 in, again, 2 seconds. We measure below the surface. So what we're getting back from that reading is this is a advanced velocity diagnostic. So all of our systems have very advanced diagnostic capabilities. So when we get a reading, we know it's real or we know we're having a problem. And that's one part of the system I really, really like and I use a lot. So what we're getting back here is, if you look, the spectrum or return signal is that one I have circled there. And what that's made up of is the 5,000 scans that it takes. On the bottom scale is frequency or the speed of the water. The more return signals that it gets back in that 2 seconds that agree on the speed of the water or the frequency, the better that signal or bigger that signal looks. This is made up of a couple things, really. It's what's in the water, we have enough stuff to reflect off of, and how turbulent is the water. In this case, we have a very, very good application. Our signal looks excellent. So one thing that's very unique about the laser system is the signal to noise ratio. When we transmit, we get the signals back, and again, you'll look at this, we get a very, very clean signal. And the bottom scale here is the noise. So the magic behind really any system is how well you can read your signal compared to the noise. This case, I can look at this and tell that we have a very, very clean signal. Our noise is very low, so that laser is having no problems getting a good reading. As that water level slows down, that peak that you see there would actually shift to the left. And what that means to me in this case is that we can read in this location very, very slow velocity or very high velocity. It doesn't matter, I'll have no problems. This is really a measurement of the quality of the velocity reading. It's stored as a value called Doppler power, and we store that with every reading that we take. So when you look at data, what you're looking for is we need to see a minimum of 1,000 Doppler power in order to consider that a valid reading. So again, very capable diagnostics. This is also transmitted via modem. So if you have a cell modem on the unit, we can dial into it. We can see exactly what that meter is reading from Lincoln, Nebraska. So we can see how well you're working. We also use this when we do an installation or a startup. So we can tell, yes, this meter is getting a good reading, or no, it's not. Okay, accuracy. We get asked this quite often. How accurate is the laser? Our current published spec is 4% of reading, which is the most accurate non-contact percentage on the market. We verify this multiple ways, but a lot of third-party testing. We've done testing with the ITRC, which is an irrigation training and research facility in Cal Poly San Luis Obispo, a very well-respected lab out there. We were 1.8% on error. For those of you on the East Coast, you're familiar with these guys, Alden Research Lab, another very, very well-respected lab on the East Coast, and we were 2.7% absolute error on that. So the laser really, really did extremely well. So let's look at some of the applications that we designed the laser for. Initially, we looked at typically collection systems, large pipes. We want to be able to read. Nobody wants to get into anything that's big. It's dangerous, and you know better than I what a pain that is to install anything in a large pipe. What we found, though, over the years is we use laser in a lot of small pipes now, and we can read in as small as 4-inch pipes. So we're seeing more and more industrial monitoring where they want to do something like that. Or some of you may be familiar with private property or personal property I&I studies, and the lasers are now being used in those as well. We're going to talk about some difficult applications. I'm not going to go into a ton of those today because we have a lot of stuff to discuss, but we'll kind of run through some of these for you. High velocity, low level, steep slope pipes. Seeing more and more of this stuff. I never dreamed I would see as many high velocity sites as I see out there, but we see a lot of them. Colorado has examples of up to 14 feet per second velocity and just really, really screaming down there. So steep slopes are a challenge. Low level raw wastewater. Typical AV sensor, area velocity sensor, you need greater than 1 inch to read. So if you get below that, most systems will interpolate, including our own stuff, which can work as long as it gets above 1 inch. We will see the laser work down much, much lower than that. Our spec is a 1/2 inch, but we will read even lower than that. Slow velocity applications. Again, more and more of those that are popping up. Residential, industrial, less than a 1/2 foot per second velocity. Slow and clean water. Again, more of those types of applications. And we'll see those at wastewater effluent plants. Chlorine contact or UV disinfection channels, another big one that's popped up for us on the radar. And again, UV channels, they want to measure typically the level going through there so they can maintain the proper water over the lights, but they're also using the flow to know how to pace the lights and things like that. So a lot of capabilities there. Drinking water influence. So we have stuff in Kansas where they're measuring the water coming in to the water plant. Stormwater applications, another big one for the laser. And the reason for that is you have a wide fluctuation in your flow conditions. You can be down to very, very low flow as well as very, very high flow. Irregular shaped channels, a lot of times you run into those conditions as well. So the laser doesn't care really what the channel shape is. We can do level to area calculation and calculate the flow with those. So here's an example of a site that was up in Minnesota, very, very low level and high velocity. It's coming off the bluffs and it is moving. So in the past, they tried to measure that with very little success and not a lot of fun. They're putting a sensor, trying to put a sensor in the bottom, and that water just goes everywhere. So very, very difficult applications. The laser can read down to a 1/2 inch for velocity, and we can read up to 15 foot per second. These are our published specs, but a lot of times we can read much lower than even a 1/2 inch. So this gives you kind of an example of what we did in this case. The laser or the Laser EX can be mounted either direction, doesn't care if it's pointed into the flow or downstream. In this case, what you'll see here is there is a mount. Same mount is used for the Laser EX as the standard laser. And there's a couple alignment tabs there that you can lift this thing out from the manhole without going in once you install it. So there's 2 bolts that hold that in place. So again, high velocity billing application, very, very challenging for them. Slow velocity application. More and more of these are popping up. Very, very difficult to measure less than a half foot per second with a Doppler device. Typically, Dopplers need at least a half foot per second. In the case of the laser, we will read down in some cases much lower than even around 0.2 foot per second. So what the big deal is with that is they can't distinguish between the signal again and the noise. So that's the big one, the signal noise. We see that in clean water applications. Okay, so the laser can do it. Why is that? Well, the laser can do it because it has a very high signal, as we saw, to noise ratio. And we can read some very, very low velocity with that. Current spec is, again, half foot per second. This gives you kind of a nice picture of one. You can see that the water surface is like glass. When it's flat like that, the only thing that really can read this from a non-contact perspective would be the laser. And because of its ability to penetrate the surface and go below, we were able to read very, very slow velocity. So some other ways, we get asked this quite often: how do you install these things and what do I need? So I thought I'd throw this out there. This is our flow lab. And what you'll see on the top, this is an opening just in the top of our flow lab. And this is really all we need to install the laser. So that's roughly a 4-inch, probably 5-inch wide opening, about a foot long. So this is what the laser looks like when it hits the water. Here's a good example of one that was an industrial monitoring application, and they have an ideal condition. If you can find one like this, you're going to work all day long. All they did was they just cut an opening in the top of that pipe. The laser, you can see the mount. There's 2 bolts that hold that mounting bracket to the wall. Laser slides right in, locks in place. The laser also knows its XY axis, so when you install that, you know exactly if you're installed level. The x-axis is the roll of the sensor. The y is the pitch. The pitch part of it is kind of important because, well, they both are, but the pitch, anything off of 45 degrees would be about any 1% off would be a 1% error in velocity. The unique thing about the laser is even if you don't get it installed exactly perfectly, the accelerometer built into it will compensate for it electronically. So it takes that error away even if you don't get it perfectly installed. This is what it looks like shooting on the water here. So this was a good install. Again, they're going to get great data from this site. Here was one that was a shrimp processing facility down in Louisiana. Trying to measure flow out of this channel was very, very challenging for them. PVC pipe, they didn't know what they were going to do. Our rep went out there and suggested just opening the top, which is what they did, cut a small opening in there, and now they read the level and the velocity in the exact same place. So really got some good readings out of that site. This one was in Las Vegas. You could see they didn't have a complete open channel there, so they didn't know what they were going to do. They installed the laser right there, and it made it very, very easy to install in a fairly tight spot. Okay, applications. This was one that was challenging because the laser initially needed to read directly below it, and then it would have focused in the wrong spot. This channel dropped about 2 feet, so they were trying to figure out how they were going to measure that. So we have the ability with both systems to do a remote ultrasonic. In this case, the remote ultra is mounted up in the pipe. It transmits off a horizontal mounting plate, reading the level at the exact same point as it reads the velocity. So this does a couple things. One, it allows you to adapt for difficult channel conditions, as well as giving you a more accurate place to measure the velocity. LaserFlow has been incredibly successful for us, setting new standards all over the place. We are being compared to multiple different technologies out there, including flumes and things like that, and we continue to impress people that are using them. Superior accuracy, much more accurate than I think even we thought we would be initially, but it's doing extremely well. Nearly zero maintenance. Our goal was to be, as low maintenance as we could be, and we're finding out that it's again more minimal maintenance than we even thought. Rugged enclosure. We have some of these that have been under several feet of water. Our spec is 6 feet for 72 hours. We've been under excess of 20 feet of water and have withstood that. Having said that, I would not put one in where you think it's going to submerge every day. That's probably not the best environment, but it can handle extreme conditions. And really, we see no end in sight with this product. So we're very, very excited about it. And we know you will be as well. And so now I'm going to turn it over to Daryl. Daryl's going to talk about the LaserFlow and some of the differences of that and why we went there. So Daryl, I'll turn it over to you.
Thanks, Rick. So why the LaserFlow EX? Well, we're finding more and more that there's hazardous rating requirements for manholes and sewers and other hazardous locations. More consultants are starting to recommend the IS ratings for flow meters in sewer applications, and which is also required internationally, which is considered as the ATEX category Zone 0, or it's also listed as the IEC EX rating for international rating. The LaserFlow EX is the only product that's going to provide this superior performance for non-contact. Which leads to the NFPA, the National Fire Protection Association code. This has been around for a while. Not many people realize the code is in place, but it's required by the National Electric Code, the Canadian Standards Association, and the purpose of it is to provide fire and explosion protection and environmental protection. So what this does is it makes sure that the equipment reduces or eliminates the effects of fire or explosion, no matter what happens in the application. If there's an equipment failure, the equipment is ensured to not create a spark, which could then cause an explosion. So what are the goals for the IS laser? We wanted to make sure that it's equal to the current LaserFlow or exceeds the current LaserFlow standards. We want to provide a true intrinsic safe non-contact solution that exceeds our competitive product ratings. And one of our biggest goals, we want to provide a finished product with zero problems. Thus, all of our testing, beta sites, internal testing with the lab that Rick had shown you. So we've done extensive testing before we release this product. We've also developed an IS barrier for the signature and the 2160. So if you have existing sites and you need the intrinsic safe sensor, we have ways to modify your existing equipment and swap out a new sensor. This product is now ready for release in Q2 2019. Contact your local ISCO sales representative or contact the factory. It is ready for sale now. So what are some of the differences? This is the current non-IS laser. You're going to notice that the color is blue. So we've changed it to the Teledyne blue for non-hazardous locations. There are no other feature changes. It's still compatible with the 2160 and compatible with the signature meter. But if you're going to use the IS laser, you could use your existing 2160 and signature with the new IS barrier. So the equipment that you can use with it, so we can still use it with AC power or with the DC power going through the barrier. Your permanent choice, you're going to use the signature meter where you have AC power or solar power, and the signature is going to give you the ability to have it as permanent or portable. The 2160 is going to be more for your temporary or portable applications, so you can move it from site to site. And then either one of these options you can use with solar power. And as always, the signature meter is quite flexible. So with the signature, as you can see here, we can use a modem with it. We can adapt it to an ISCO water sampler. If you need redundancy for an ultrasonic sensor or area velocity sensor, we can provide some redundancy. Or if you need to read pH, we have a pH TINET sensor. And of course, we can add the LaserFlow sensor to the signature solution. So this is what the new EX laser looks like. It's black in color. You're going to notice the large label on the side, which is going to say LaserFlow EX. That'll be the easiest way to tell which one you have. It uses the standard ultrasonic sensor on the back of it, which is nice because it plugs into the back. And then if you find that your application does require a remote ultrasonic sensor that Rick talked about earlier, now we can purchase the longer cable length and retrofit this EX laser to be used as a built-in or remote ultrasonic sensor. The one limitation with the LaserFlow EX is that it reads the 3 velocity points vertically, which I'll show you on the next slide. So what it looks like, it's still going to take the ultrasonic reading as before to read the distance to the surface of the water. The laser will now transmit, and it will read that below the surface vertically, we can pick 3 points. So we've eliminated the side-to-side, just the 3 vertical points below the surface of the water to read our velocity. And we refer to this as the multi-point, multi-depth method. Some of the performance improvements, the LaserFlow EX has electronic changes that improve that signal of the laser. So Rick talked a lot about the signal-to-noise ratio. We have improved signal, which gave us an improved, increased the Doppler power. So when you're looking at your data and you notice the Doppler power is higher, that's by design. The way we're able to make this an intrinsic safe unit is that, we had to reduce the amount of power. And to do that, we use what we call a super cap to store the power, which reduces the current draw inside the unit to meet the IS standards. The LaserFlow EX will still take the 5,000 velocity readings. It takes about 20 seconds to get your velocity reading, so it's pretty impressive to get 5,000 readings within 20 seconds to get your velocity reading. And all the other features that you're used to with the laser remain the same. So what is the NFPA Class 1 Div 1? Why are they required? So as far as when we talk about Class 1 Div 1, they're broken up into into class and division. So your classes are going to be your combustible gases, dusts, and fibers, and we're concerned with Class 1. And the divisions determine how often are these combustible gases or dusts going to be found in this application. So Division 1, the gas or vapor is always or can be present under normal conditions, which is greater than 10% of the time. Now Division 2, which isn't as severe, indicates that you has the potential for hazardous gas to be present. Now, for international, the ratings are Zone 0, which is the same as the Class 1 Div 1, and then Zone 1 is similar to the Division 2. As far as the Class 1 Division 1, the standard shall apply to the following: collection systems, combined sewers, some storm sewers, pumping stations, wastewater treatment plants, sludge handling facilities, chemical handling facilities. So any place that has potential to build up hazardous gas is going to be classified as Class 1 Div 1. And then, of course, at your treatment facilities. So before we mention the NFPA collection systems, their partial list is the sanitary sewers are listed as Division 1, combined sewers, and storm sewers. So if they're not normally vented, that means there's a chance to trap gases, which could create an explosive environment. So some sewers are not vented and may fall into this category. So other classified areas are going to be a wastewater treatment plant, the headworks, the grit removal, primary settling, your odor control. And some of the current locations that we are finding that are requiring the intrinsic safe ratings are in Canada, Australia, Singapore, Massachusetts, New York, Phoenix, Milwaukee, Seattle. And as far as the list is going to just keep getting larger instead of smaller. So thus the need to address this, make sure we get in front of this where we have intrinsic safe equipment. Now this is one of the applications where we were testing the EX laser. This particular picture has showing the non-EX laser, the standard laser and the EX laser. This happens to be in Waverly, Nebraska. We were able to put both lasers on the same channel. Had fantastic results out of it. The level and velocity and flow rates mirrored each other. Had incredible results out of that. And we had multiple other applications in Poland. We had similar results where we had 2 lasers on the same channel. In Phoenix, we were doing the same thing. So we have lots of data showing how the EX laser meets and exceeds our expectations and standards to match the existing LaserFlow sensor.
Well, thanks, Daryl. Great job and great discussion on the Laser EX. We're going to give you our email addresses at the end. You feel free to email us anytime you want. But we're going to go ahead and wrap up here a little bit so we can answer some questions. But really, in conclusion, the LaserFlow is continuing to gain market share rapidly, and it's viewed now as one of the superior non-contact flow technologies available in the market. LaserFlow EX now provides you with a complete solution, so you may have a lot of places will have some where they consider to be hazardous areas and some not, so they can add that to their existing fleet. You can take an existing unit and modify it as Daryl mentioned. And now you have very accurate data with no risks and very minimal upfront costs, so it really saves you a lot of stress and worry out there. So we're going to go ahead and wrap this up with some questions. So one of them was, I have an existing laser right now, and I want to probably go ahead and switch it out to an EX. Will my existing mounting hardware work? The answer to that is yes, it will. You'll notice though on the Laser EX, the ultrasonic sensor is mounted in the back of the unit, so you'll have a little bit less room in there. So when you mount that mounting hardware, you're going to want to make sure you give it a little bit more room. So good question. Another one is the accuracy, is that equal to the non-IS laser? And the answer to that question is, if your application is relatively normal, the answer is yes, it is. The non-IS laser can do the horizontal points as well. So if you have a non-uniform channel, it may not be quite as accurate as the non-IS, but it's certainly has been shown to be very, very accurate. Okay, another question. I have existing Class 1 Division 1-2 sensor out there. Does that meet the NFPA rating, 820 rating? The answer to that is technically no, it does not. The rating is Class 1 Div 1. If you have Class 1 Div 2 device, then you're taking a little bit of risk there because it does not meet that rating. So the answer is kind of your call, but no, technically it does not meet the rating. All right, so let's see. Another question. So I have an existing signature. Can I modify it to work with the Laser EX? And the answer is to that question is yes, you can. You'll need to buy the barrier and the Laser EX, and you'll have to have the signature out of the hazardous area. So you have the signature in the safe zone. You have the barrier connected to it, and then from there you have the cable going into the hazardous area for the Laser EX. So yes, you can modify that. You can also do that with the 2160. The 2160 would have to be out of the area as well, and there's a barrier that would attach to that going to the Laser EX. Okay, can I use a cell modem in my existing software? The answer is absolutely. The cell modem would be in the signature or the 2160, again, out of the hazardous area. But the software FlowLink is exactly the same. The FlowLink Global, FlowLink Pro, where we push data, works exactly the same way as it did. So No learning curve with the Laser EX. It's very straightforward, just like you're familiar with if you have a standard laser. I think that's about all the questions. So how do we get the data? Okay, well, the way you can get the data is the same way that you've done in the past, which is either physically go download it. In the case of a 2160, you would use a cable with flow link and plug into it, or a modem. Case of signature, you can use a cable with flow link, or you can use a little jump drive, thumb drive, and download it.
The signature also has the option for Ethernet. So if it's hardwired, you can use the Ethernet output or Modbus output. Or with the signature, you do have the option for analog output as well for getting your data.
All right, I think we had some really, really good questions there. We're going to, I think, wrap up now. Want to make sure you have our email addresses. Again, that's rick.dye@teledyne.com or daryl.kuda@teledyne.com. And Daryl and I team up and cover the entire globe, so we're on the road quite a bit, but you can reach either one of us about any time, and we'd be more than happy to help you with any questions you have, whether it's related to the LaserFlow or just your flow applications. And again, we have an excellent staff out there, reps and dealers that can help answer your questions from a local standpoint. As I mentioned earlier, we are available on YouTube, so you can get any of the stuff that you saw today. If you didn't get enough of it today, that's a joke. You can certainly get us on YouTube as well. And there's some good videos on there that we're producing as well that kind of give you a 2-minute snapshot of some of the features of the laser. So hopefully those are helpful to you. And we certainly appreciate you guys attending today and look forward to working with you in the past.
And the YouTube links can be found on the ISCO website.
So thank you.
Great. Thanks, everyone, and have a great day.